Assalamualaikum. Very good morning, everyone. Testing mic. 1, 2, 3. Testing. Can you hear me? If you can hear me, write there in the chat. Yes. Boleh. Alright. Thank you. I have roughly 8 students. So one more student not in. Section 2. Okay. Morning, everybody. Okay, Assalamualaikum. Very good morning to all. So I'm going to start the class for today. So I see that everybody mostly are here. Only one student are missing, but I'm not sure who. But anyway, I will directly start because we only have 1 hour class for today. And then tomorrow we have another class, which is 2-hour class, 9 to 11. Can I just check? Do you hear any background noise, or is it only you hear my voice clearly? Any background noise that you can hear? Clear? Tak ada bunyi kipas Tak ada Tak ada. Okay. Right, let me just share this screen. Okay. So as usual, when you start this every classes, so you're going to go to the week. Right now we are week 5, and you may see that in I have actually enabled the week 4 replacement class, but do not do it yet. Replacement class week 4 is basically for you to do the self-assessment for chapter 3 topics, which you haven't done yet. So we will go through week 5 class first, which is on the we see here is that learning outcome for this today week 5 this week class is that you are going to explain the requirement for signal conditioning and the types of signal conditioning for mechatronic system. So after you have you're able to explain that, then you're able to analyze and select suitable signal conditioner for any mechatronic system. Okay, so in today's class is that basically I will give you one problem. Then in that problem is that you need to define what are the solution for that using the signal conditioning. And for tomorrow is that we are going to continue with chapter 4, which is on the requirement of the data presentation system. So this week we are covering 2 chapters. Chapter 3, which is signal conditioning, and chapter 4, data presentation. Even though it looks a lot cramping, but anyway, the data presentation is not much. So you can see later in the ULearn, I have shared the learning curve topics that you can go through the video related to the topics. So as usual, please take your attendance. Right now it's open from 8 to 9. Okay. So in the before we go to lesson 5.3, so I have upload few notes. So notes for chapter 3, okay, which is on signal conditioning, and also the notes for chapter 4, which is on data presentation system. And other than that, I also uploaded a part of the topic from the main reference book. So if you click on this topic, on the PDF, so what you will see is that part of the chapter 3 signal conditioning. Okay, so this one is the main textbook that I refer to, and basically the notes that I have prepared in the slide is basically from this book. So as you know, PowerPoint means that PowerPoint lah, in point form, means that it's not in detail. So main textbook is the reference book that you need to refer to when you do revision, when you do any revision group discussion with your friends. So, or self discussion lah, means that self study by your own. You also need to have one main textbook. So this is the main textbook that you need to refer to. So I uploaded the reference for chapter 3, and also for chapter 4 also I have uploaded for both the for data presentation system. So part of it, okay, so you may go through the document. Okay, so what we are going to learn for today is on the where did we go? Chapter 5. Okay, so we are going to do activity in Padlet later. Okay, and you're going to upload the problem 1 in the slide. So basically, for today is that I'm going to explain the 3 slides. Okay, and also other than that, I have also shared to you the chapter 3 learning curve. So learning curve means that there's a few series of video that I shared in the ULearn link below, down below. Okay, so based on that, you need to answer problem 1, which is in slide number 12. Okay. This is individual, okay, and you need to upload it to the Padlet. Deadline is by tonight, midnight, 12 midnight. So please go through. So, and we will discuss the problem tomorrow at 9 a.m. plus. And after you have gone through all the activities and so on, okay, all the chapter 3 learning curves, then as normal, please complete the self-assessment quiz. Okay, for chapter 3, and the deadline will be this Saturday. So I open it, basically it's open always, but I need to give you a deadline so that you do commit to the deadline. So you can do it multiple times until you get the higher score marks. And I think there were a request from student related to the previous quizzes. So I open it also, I enable it, so you can go through the quiz again for chapter 1 and chapter 2. Okay. And for tomorrow lesson is that we are going to do continue on chapter 4, and basically chapter 4 will be pre-recorded, means that aside asynchronous class. But anyway, before tomorrow class, I will discuss about the problem 1 after student uploaded the solution to Padlet. Okay, and as normal, we have the class reflection, so please do it for today is by this midnight, and for tomorrow class is that I open it until 1 week until next week Sunday. Okay, this week Sunday. So this is the document that I have shared in the chapter 3 learning curve. So means that apart from the PowerPoint slide that I'm going to explain, okay, I also shared the video related to each of the signal conditioning. Okay, example is video 1 protection, okay, video 2 is on A to D and D to A converter. Sorry, wait for a while. Okay, so A to D and D to A converter, and video 3 is PWM, video 4 amplifier, okay, summing amplifier, and so on lah. So we have total 9 video under signal conditioning, and also there is another topic which is for tomorrow is on chapter 4. So I have pre-recorded chapter 4 here. So you can go through first for tomorrow, and there are few documents, video related to the data presentation. Okay, so that is a bit explanation on what you're going to learn for this week. Okay, so let's go to the chapter 3 directly on signal conditioning. So basically, chapter 3 is mapped to the LO3, which is on analyze, selection, and integration of mechatronic component PO2. And by the end of PO2, that you are able to explain the requirement for signal conditioning. So there are requirements on why you need to use the signal conditioning. And second one is to explain the types of signal conditioning. So the one that I showed to you, the video 9 video, is types of signal conditioning and why where you can use it. Okay. And number 3 is able to analyze and select the suitable signal conditioning for mechatronic system. Okay. So if we go through this notes, okay, this one is the general block that you have gone through before. The whole block that right now that you see in front of you is called the mechatronic control system. Is the complete control system. When we talk about mechatronic system, means that it has all of this element. It has the element of measurement system, okay, over here, and it has an element of actuation system, and it has the element of control, which is over here. So all of this, when combined, we call it as mechatronic system. So normally when we talk about mechatronic system, it must be controlled in the end. You need to control what are the input reference here. Okay, and you have learned in the beginning of chapter 1 and 2 is that you have learned about the sensors. Okay, last chapter 2 is on the sensors, type of sensors, and sensors is a part of the measurement system. Okay, and a part of that is that the output from the sensor, you will have signals. Signals, it can be in current, it can be voltage, it can be liquid. Okay, but normally when we talk about signal, it can either be either two signals. It's either in current, voltage, and sometimes in resistance type. Okay, so all is related to the V equal to IR, Ohm's law. So when we have this type of signals, normally we need to have the signal conditioning interface. When we have a mechatronic system, okay, we talk about mechatronic systems that is normally using computer, digital, okay, digitalized. So when computer, it can only read digital, 0, 1, 0, 1, okay, binary, okay, and it cannot read any analog signal, okay, like voltage or current, okay, it's only on analog. So what you need to do is that you need to convert the analog signal from the sensor output, convert it into a digital. Digital means that where it can be read by the computer. So if you are familiar with types of talk about interfaces of signal conditioning, the common one that you normally hear is Arduino. Okay, Arduino is example of a DSP board. Okay, a simple DSP board where it can actually read, convert A to D and D to A. Okay, why? Because you can attach sensors to the port of the Arduino port, input-output port. So basically analog to digital, and that digital can be read to your computer, okay, using the cable. So we have those connection to the computer. When we have connection to computer, you must have a to D converter. Okay, so signal conditioning is really important. And you may see that signal conditioning also there is also in the actuation system. Okay, so you see that the output from the signal conditioner over here is going into the comparator over here. Okay, it's going to compare with the reference input. And when compare, you have the error here. And basically, when you have this, let me just take out my pen. When we have the digital part, we already converted it from analog to digital. So what you have here, okay, so imagine that you have the analog here this is analog, okay, and then you convert it to digital. So this is analog to digital. Okay, so everything here is digital. Okay, and also at this point digital because you are the one who is setting the input reference. So it's going to be in digital in your computer or in your MATLAB or your software or Arduino. It's all in digital. Okay, so the output here, everything is in digital signal. So when we talk about digital signal, then before it goes to the actuator, actuator can only read a signal in analog most of the time. So that's where you need to have the D to A converter, digital to analog converter again. So this is where you have the signal conditioning in the actuation system. And other than that, you also sometimes need to have amplifier, okay, or filters. Okay, filters most of the time. when you have a reading from sensor, the reading is very noisy. So you might need to have a low pulse filter to filter out the high frequency. Okay, and you might want to amplify the signal because of the signal is too weak, too small. It's milli voltage or milliampere. So you want to increase it. You want to amplify it. So you need to have an amplifier. Okay, so signal conditioning is a really important part in a mechatronic sources system and for both the measurement system and the actuator system. Okay, so this is what you have done in previous class on the summary of sensor and transducer. Okay, so I'm just going to skip that. So what you're going to learn for the signal conditioning is that there are 5 main things that later you're going to learn. Okay, so basically signal conditioning is that the function is to process signal to make it suitable for the next operation. So what does it mean by next operation? Next operation means that for the operation to read by the computer, to read by your system, okay, your software. So it need to be read. Most of the time in control we are talking about software like MATLAB. Okay, you have a block diagram in MATLAB that is good. You need it to read in digital. So you need to prepare the process that is going to be it can actually read in digital. And most of the time, the DSP board for Arduino, okay, Arduino Uno, Arduino Mega, can you share with me in the chat what are the maximum input for Arduino board? What is the maximum it can read in voltage? Is it 5 plus minus 5 volt? Or is it 0 to 5 volt? Or is it 0 to 10 volt? Can you write that in the chat? Anyone have an idea?
Minus 5 kot.
Plus minus 5 volt.
5.
Are you sure, Syafiq? Anyone else?
Saya tak pernah guna yang Arduino.
Tak pernah guna. Okay, tak apa. Boleh Google. Kalau sebelum jawab tu boleh Google dulu jawapan dia. Anyone else? Arduino? Anyone else? You can Google it before answering it. Okay, Louis answers 6 to 20 volt, 5 to 5.5 volt, 7 to 12 volt, 12 volt. Okay, so most of the time Arduino or some types of the DSP board it can go up to 12 volt lah. I don't think it can go up to 15 volt, but it's going to read from 0 to 12 volt. Okay, 0 to 12 volt. It doesn't have plus minus 12 volt maknanya tak adalah it cannot read minus 12 volt to positive 12 volt It only start from 0 to 12 volt. Okay, and in some powerful DSP port it can read actually the negative part. So example that we have microbox in our lab, it can read plus minus 10 volt, means that the range is 20 volt. So plus minus 10 volt. So when we talk about that DSP board, so you know that there's a range that it can accept the input signal. So imagine that you have this signal conditioning, you have the Arduino over here. Okay. So the sensor reading here, okay, must not, if for example just now you say that the range is from 0 to 12 volt. Okay, so where can you actually find this? So you have learned in the sensors and transducer chapter about datasheet, right? Okay, so try, okay, this is a homework that you can do. Try to download the datasheet for Arduino. There's lots of type of Arduino Uno, Arduino Megas, different types, different range of inputs to the system, okay, and output also. Okay, so try to search the datasheet and try to look at what are the range, okay, that it can receive signal, the input and output port. Okay, so when we talk about that, a maximum is 12 volt, means that the sensor reading here that can only be sent to this Arduino, maximum is only 12 volt. If it's more than 12 volt, what happens is that your Arduino will fry lah basically, fry. Okay, so this was really important to actually, before purchasing any component or purchasing any sensors or purchasing anything, you need to read the datasheet. Okay, before you fry the DSP board, you beli Arduino, harga dia dalam mungkin RM60. Okay, clone one RM60 saja. The expensive, the original one is I think 100 something. So if not, so you need to read first the sensor. But most of the time, sensor, if we talk about very the simple sensor, IR sensor, ultra sensor, the reading can go up to 10 volt. Okay, so sensor, you need to also download the datasheet. And of course, the board, Arduino board, also you need to download the datasheet. So you need to go through the reference. Okay, you cannot just simply buy the DSP board, Arduino, buy a sensor, then connect everything, then you confirm that it's going to work. Okay, sometimes it's not working, and you don't know what's happening actually. You think, oh, maybe my coding is wrong and so on. But the important is that to troubleshoot one by one. So before you do the connection, make sure that you do the simulation first. Okay? Because Arduino, you can do the simulation, okay, using IDE, the Arduino IDE. So you can do simulation first, test it out using the the sensor that you purchase, and then after it give you the good output, then you only connect it in physical. Okay? So this is really important. Okay, and so that's the idea. So the first one was just getting the level of signal right, okay, at millivolt or at voltage level. So not only for the board, the DSP board itself, but for the sensors, okay, or even for your actuators. Actuators also can only read certain value only. It can only read, example, in voltage. It cannot read in current. Some sensor, they can read current value. So you need to read to download the datasheet. Okay, before purchasing, it's important. If you purchase something, some component, without even looking at the datasheet, and then after that you finally realize that it cannot be used later on for your system, then it's going to be wasteful. Okay, then you need to purchase again and so on. So first, do research before you purchase anything. Okay, and the important is that most of the time, this is when you do your project with your IDP, your IDP project later on in third year, and for your final year project, okay, you have a supervisor. So you need to go through your supervisor. Make sure that your supervisor check first the component that need to purchase. Okay, normally I will ask student to make a list of component purchase. What are the input and output value for each of the component? Is it really confirmed that it can be used for the system? Okay, because most of the time I'm not going to pay back to student if they buy the wrong component. Okay, so only buy once and make sure that it's correct. Second one is that eliminating or reducing noises. And this is by using filter. Okay, so just now we were talking about some sensor like IR sensor, okay, infrared sensor, lots of noises. Okay, when if you have Arduino, okay, I would suggest for you guys, for mechatronic student, since you are mechatronic student and you are just enter UTEM, okay, if you have not used Arduino before, please buy one set of Arduino. Arduino Uno set. They have the very simple set. I think it's about tak sampai 100 lah, dalam RM60. Complete everything with the they give you the resistor, some a few IR sensor, and the cable and so on. So they give you the basic, then you can do a testing on your own. Okay, and you can use IDE. Okay, IDE software. Let me just check. I think I have it in my IDE. Okay, this one. I'm gonna see. IDE. Okay, it's not opening, but you can try to download this Arduino IDE. Okay, that one is for you to do the simulation. Okay, you can download that. You can just try out lots of just Arduino. Okay, this one you can download this. Okay, Arduino. Okay, Arduino IDE. You can just type that. Okay, and then it will go give you the Arduino IDE. You can download this window, or you're going using Mac, then you can just download that. And then there are lots of documentation inside here. Okay, so getting started. For example, you say that you never used Arduino, so don't worry. Okay, try to go through everything. They give you a sample of code, install how to install the Arduino, what to learn, okay, education, okay, and so on. They give you references, lots of references, the code, the function code that being used. Built-in example also are given once you download that. Okay, they give you example of built-in example how to use the digital. So basically, Arduino IDE is something that it's software. Of course, later when you purchase the physical board, you have the Arduino Uno, Omega. So you can select later on, select which one you are using. So if you see here, lots of everything is actually covering the signal conditioning. You have the digital, analog, communication, control, sensor, display. So everything is inside here. Okay. So you can download this. Okay. Don't wait until you need to do your project only to download this. You can do a simulation. Okay. So those are one thing that you can do right now. Okay. Don't give excuses that you haven't used it. Okay. Student mechatronics should be, I would say, proactive. Proactive. Don't wait until your lecturer give you a project, then only you do it. You need to actually um, find out interesting topics, okay, from YouTube. Try to search Arduino IDE for mechatronics, the project. Simple Arduino IDE using mechatronics project. So you can go through some very simple basic simulation inside there. Okay. Once you are excited about that, then you can convert it to later on to a physical project. Number 3 is getting the signal into the right type of signal. So this is what just now what I was talking about, A to D and D to A converter. Okay, and then number 4 is signal manipulation. So sometimes some of the signals from sensors, from the actuator are non-linear signal. So what does it mean by non-linear signal is that, okay, when we talk about linear signal, if you have XY axis plot, okay, like this, you talk about a signal that is linear, IR sensor is linear like this. Okay, you're going to have a linear signal, means that you will know that if you're going to give this a voltage, then it's go to up to 10 volt, then it's going to be linearly increased. Okay, so but some sensors or even some actuators, they have the different characteristic whereby their characteristic is non-linear like this. So means that it's not linear, it's actually the opposite. So when you have this type of characteristic, means that one, it's difficult to control. If you have a system that is non-linear, then it's difficult to control. So that is whereby you need to actually linearize it first. Okay, you have a non-linear system, then you need to make it into a linear system. So how to do that? So there are methods to actually to actually add a non-linearizer block in between the control block and the actuator. So it's going to cancel out the non-linearity. Okay? And the last one is that protection to prevent damages. So this is normally when you know, like fuse in at your home, okay? You have fuses, okay? So basically, if you have more than the current or voltages, then the fuse will actually collapse, okay? So this is protection to prevent damage. Okay? So element that we are going to go through is this type of element: op-amp, filtering, with stone bridges, digital signal multiplexer, and so on. So just go through all of this. Okay, later on, okay, on chapter 4 is that after you finish everything, sensor, next signal conditioning, and how to actually display all of the signal is that you need to have the data presentation system later on. Okay, so these are example of signal conditioning that you are going to look at later on. Okay, so let's look at example of sensor. We have a thermocouple over here. Okay, thermocouple is the sensor. So you might need to have the protection for excessive signal and wrong polarity. Okay, so for wrong polarity, so you want to make sure that you add a Zener diode example. And then you might want to have an amplifier to amplify the signal from the thermocouple because it's very small, millivolt. You want to amplify it. Use an amplifier so that it can be read by the signal processing. Let's say we have the DSP board over here, DSP board or Arduino. Okay, so we want to read it in terms of voltage. Okay, so you need to add the amplifier. Okay, and you might have some noises in the signal. Okay, noise means that let's say that when you take out the graph, the temperature from this thermocouple, okay, uh, assuming that you start from 0, then you are going to read the temperature like this. Okay, temperature maybe right now is 26 degree. Okay, it's reading like that. But because of the noise, okay, noise happening, so you have lots of noise inside here. Okay, lots of noise, which is this peak and this peak. Sometimes it's going up again. Okay, so how do you actually remove this noise? So you know that these are noises that actually is not reflecting to the current temperature. Okay, it's not reflecting to current temperature. You want this temperature only. Okay, so how to do that is that you need to filter the frequency. So you need to find out what is the frequency of the noise. So how to find the frequency of the noise? So you need to find the cycle of the the noise. Okay, for example, this is peak to peak of the noise just now. So we take this as the t value. So frequency is 1 over t, right? So just find that, then you will get the frequency value. So from there, you're going to design correct, Vivian. So from there, you are going to design the low pass filter based on this frequency to filter the noise. Okay, number 4 is that you want to have an analog to digital converter. Okay, we know that the thermocouple is analog type. Okay, most of sensors are analog. So to be read by a computer or even to be displayed by a LED means that it's going to be a digital. So you need to have A to D converter. Okay, A to D. ADC is A to D converter lah. Okay, and here sometimes you need to have a D to A converter. Let's say that after displaying this temperature, okay, temperature is 26, over here. Okay, you want to actually control the temperature of the room. Okay, this is thermocouple. Okay, you want to control temperature of the room, then means that you need to have a feedback over here. And then it's going to compare with the reference. So you want to control the temperature to 25 degree actually. Okay, so this thermocouple, not here. It's here. This thermocouple, this is reference. So you are going to actually control it at 25 degree. The thermocouple reading is the one that is going to be displayed here. Okay, so you are going to control it 25 degree. So you need to have a controller. Okay, so that controller is where you need to have the D to A converter to convert it to the analog so that it can be read again by the thermocouple. Number 6 is multiplexer. For the case of you want to use a LED display. So you know that LED display have multiple input going in. Okay, so you need to display it. Okay, multiple input multiplexer. And lastly is the deck card is the one that I explained just now is the DSP board. Okay, so this one is one example of a system that you have a sensor, and then you have also signal processing, and also you have the display at the end. Eh? And this one is normally, if we take one example, is the temperature sensor that you use for the to measure your temperature lah. When you right now we have the COVID, right? So temperature, you read temperature and you see, oh, okay, my temperature is 26 degree. Okay, so you are not actually having high fever. So this is example, eh? Okay, so okay, so this one is where you can actually use all the signal condition that I mentioned just now. So if the signal is too small, so you need to be amplified, so you use amplifier. If the system or the signal contains inferences which need to be removed, that's noises, so you need to have a filter. Okay. If it's non-linear, you need to linearize it, so you need to have a linearizer. If it's analog form, then you need to have a digital signal, then you need to have a DA to D and D to C. Okay. And if it read-only resistant changes, so you need to actually use a current change. Okay. So you can use a Wheatstone bridge. Okay. And lastly is that voltage change to be changed into stable current. For example, maybe the current value or it can only read in current, and you can use either Kirchhoff's law or Ohm's law. Okay, so all of these are the signal conditioning components that it can either only one types of signal condition or combination of multiple signal condition in one system. Okay, so this one is example. Okay, another example of signal conditioning that we have. Okay, for the case of this, okay, this sense of okay, so this example is the output from sensor to controller. Okay, so for this, if you see here this example is a mobile robot, very small robot. If you're familiar with Arduino, okay, they have actually sell a set like this. Okay, the set have the Arduino board. Okay, it give you two DC motor, and you give you electronic sensor also, and the other components is you need to buy it. Okay, so like motor driver is not there, so you need to buy that motor driver, and the rest is a combination of how you can actually use it. Okay, this one is example of my FYP student. So basically, the one that he bought that already there is only the sensors and the DC motor. The rest he need to actually program it accordingly. Okay, and for this is that, okay, a microcontroller require digital signal. So means that in digital, means that the Arduino Uno here require digital signals. And you know that DC motor only can give out analog signal. Okay, so you need to have a converter A to DC, A to D. Okay, and those in the Arduino already have that port. Okay, port there, A to D converter already have that. So you need to go through and read what are the gain value that the convert. Arduino can read 0 to 12 volt, example. And is the DC motor also have the same range, 0 to 12 volt? So if the same range, then the gain is 1. Okay, so that's easy. But if the DC motor can only go up to 10 volt, it can give you the reading 10 volt. So you need to do a calculation. What is the gain? Okay, gain between the Arduino Uno and also the DC motor. Okay. If it's too small signal, then you need to amplify it. If the signal from the DC motor is small, then you need to use amplifier. So this is where you need to use some op-amp, okay, to actually increase the amplifier, to increase the voltage, and improve signal if to have too much noises. Okay, so you need to have a filter. Okay, so all of that you can actually design your own circuit. For the amplifier, there's an op-amp circuit. Later, you go through the slides, op-amp circuits, and also for filtering, what are required to design the filtering. And for the output is that, okay, actuator require analog signal. So from there, you need to convert back again from digital, from the Arduino, because it can only give you output digital. So to read it back, give it the signal back to the DC motor on what to rotate, voltage to rotate, then you need to convert it from digital to analog signal. Okay, and if it's too small, then you need to amplify it. Okay? So this is example. Okay. So okay, basically this is what I explained just now, already explained. So you have the multiplexer and then a computer. Okay, so this is the problem that you're going to find out later on to solve it. So you have as problem 1, figure 1 shows electromagnetic radiation sensor which is used for explosive detection application using mobile robot. The sensor works by converting electromagnetic wave to electric signal. Okay. The sensor is used for detecting signal in kilohertz and above range. Okay. So means what? Means that there are a few things that you need to pick up from this information. The analog signal is received is very weak and suffer from power cable noise. So if you see here is that first one is that require protection. Why? Because of it's used for explosive detection application. So means that you need to have protection. You cannot actually simply give any input and then if no protection, then it will blow out. So that is one thing. And most of the time in mechatronic system, you need to have a protection system. And second one is that require filtering. You see that it mentioned that the sensor is used for detecting signal in kilohertz and above. So it means that it need to have a high pass filter. Okay, it's going to actually pass all the high frequency. Okay, and the low frequency will be filtered out. Okay. Third one is that the signal received is very weak. So that's why you need amplification and suffer from power cable noise. Okay. And because you are going to use the DSP, the board, so it means that you need require A to D and D to A. Okay. So in here is that explain the 5 different function of the signal conditioning. So what you have learned in this part. Okay. From this 7 point of terms of signal conditioning, which one that is required in this example, and why? Discuss the signal conditioning requirement and outline the solution to input the signal from electromagnetic sensor to a computer. So this is where you need to actually draw the block diagram like this. Draw the block diagram. Okay. So you have the sensor. Okay, what you need to do, and so on. So draw out the block diagram. How do you think it looks like? Okay. And then the third one is that design a circuit to amplify the output signal 1000 times the original value. So you need to have an amplifier that can actually amplify 1000 times. Okay. So in order for you to go through this, okay, so go through the other slides. The slides is basically the general information for protection, A to D converter, okay, D to A, PWM, amplifier, and also with the combination of the notes that I have shared. So you have all the filtering, okay, low pass filter, high pass filter, okay, multiplexer, DAC, okay. So based on that and based on you learn, okay, in you learn, okay, go through the slides first. Not the slide. Okay, what I want you to do for today task after this, okay, is that go through the Bolton reference, okay, student, okay, and read through all of this signal condition. Read through. It's like a story, very nice story, okay. So read through this document, and when you read through this document, please also refer to my PowerPoint notes, okay. you'll find out that all of the information in my PowerPoint is actually from this textbook. Yeah. So read through. Okay. We have the filter, comparator, everything over here. After reading that through, you will have an idea how to answer for the problem, this problem 1. Okay. So that will be the task that you need to submit by tonight. Okay. By tonight. No problem if it's wrong, we will do a discussion, but at least students do try the best. So how to go by this problem is that, as mentioned, read through the text first. Okay. And then you're going to look through the problem 1 and later upload your answer, okay, in the Padlet. Okay. And the Padlet, right? Upload it here. So tomorrow at 9, we are going to discuss that. Okay, so basically this for today class is combination of synchronized. I have explained a bit on the chapter 3, and also, okay, other than referring to the notes, Bolton notes, of course, don't forget that you have the learning curve chapter 3. Okay, for each of the video, I already link it to all of the information. Okay, you have the reference book just now, Bolton, and you have the video. So you can read through the protection, what it means by protection using Zener diode. The A to D to A converter, what is it? What is PWM? What is amplifier, inverting and non-inverting? What is summing amplifier, differential amplifier, filtering, okay? Multiplexer, and DAC introduction. And after you complete this, only go and answer problem 1. Try to solve problem 1. Okay? So that will be all for today class. And for tomorrow is that we are going to discuss the problem 1 and see how the student actually done on it. Okay? So any question? Any question? No, okay. If no question, then make sure that okay, for the feedback form, I think if you cannot complete because to answer feedback form is that you need to complete everything. So I will open it until Sunday. Okay? So make sure that you take your time to go through, but make sure that for by tonight, okay, if you want to actually skip the textbook, should be okay. But go through the video of the learning curve, the 9 video just now, okay, and my slides. From there, if you want more information, then go through the textbook, okay, notes. And because I'm sure students normally they think that whatever the lecturer deliver in class is that they need to know, but actually you need to have a textbook as the main reference, and that will be the more detailed information. And for your information, when the lecturer are designing question, okay, for the final exam or even midterm exam, we do not only refer to one textbook. Okay, this is I have the textbook, okay, my own reference. If lecturer have their reference, student of course you need to have your reference also. Okay, because we are developing the question mostly based on the content from a textbook, main textbook, but it's not limited to one textbook. For my case is that I refer more than 10 textbooks when I design question. So if good student is that if you are in UTEM, please go to the library, okay? Library and find books to actually to borrow out, okay? And let me just share to you a bit, okay? Don't limit yourself to only my textbook, the main textbook that I shared. You know that in the teaching plan, I have shared, you see here, 8 textbook. All of these 8 textbook is in the library. This is some of the textbook that I refer to, some, not all. I actually borrow out more than 30 books. So go through, find out books from the library if you are in UTEM. And if you can actually do that, then I'm sure you can score for the subject. So don't expect to score for subject if you don't put effort more. And as you know, for the SLT, okay, student learning time for this subject is that whatever credit hour that we have, for example, our credit hour is 2 credit hour, and our meeting or class lessons is 3 hours, 3 hours lah basically per week, including tutorial. So means that you need to spend 3 hours at least, 3 hours at least for preparing for the subject. Means that 3 hours is with me and 3 more hours you spend on your own self-learning time, student learning time. Okay? So if students do this, then they should be able to score for the exam. Okay? And please go through the quizzes later on after you finish everything on chapter 3. Please go through the quizzes in the week 4 replacement class. So that one will be for quiz chapter 3. Okay? So any more question? If there is no question, then any more question? Siapa yang ada dah? Kenapa ada 9 orang Bukan ada 8 orang ke? Anyone here who's not... Anyone here from Dr. Fahmi class ke? Yang baru transfer? Okay, by the way, there will be about, I think, including you guys, 8 students, roughly about 30 students total for section 2. They will join us in week 6 next week. So later our class instead of 8, we have total 30 students later on. So I hope that I'm not sure if this student, I think there are extra 1 student over here, but I'm not sure who. But anyway, if there is no question, then make sure to upload the task in Padlet and we will discuss the solution tomorrow. Okay, that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye. Ada soalan ke? Tak ada kan?
I want to ask about today we just need to solve the problem 1 only, right?
Yeah, yes. Only
For the
problem 1.
For the feedback form, we can until Sunday.
Yeah. I will change that deadline. I will open it until Sunday.
Thank you, Doctor.
Alright. Okay, thank you. Okay?
Thank you, Doctor.
Alright, bye. Bye.